Hey Algebra 2, today we are going to talk about some data and outliers. A lot of it is stuff that you already know, so I just wanted to go over a few things. The mean, you should recall that the mean is one of the ways that you can calculate the average. So we typically call the mean the average. And here you are just going to add and divide by your total number of things. Most of you have been through driver's ed. You know the median is in the middle of the road, so the median is the middle number. You may need to specifically order them first before you figure it out. So put them in order from small to large before you do anything. The mode, I generally do word association. Mode is most often. So it's the number that is found most often in a group of numbers. The range, it is what is the distance from the maximum or the biggest number to the min or the smallest number. So all you're going to do is identify the smallest and the largest, and you are going to subtract, and that is how you calculate the range of something. An outlier is perhaps a little bit new. An outlier is a data point that differs significantly from the rest of the data. So it is usually a bigger number or a smaller number than the rest of the numbers, and we're talking like usually by a lot. Alright, so let's try a couple of these. The number of minutes each of 13 students in a class spent working on the same algebra assignment is shown below. So one kid spent 15 minutes, one spent 12 minutes, etc., etc., etc. So here's all the time they spent. Identify any outliers in the data. So when you look at this range of numbers, is there anything that jumps out at you as being a lot bigger or a lot smaller than the others? Hopefully so. That 65 minutes that a kid spent is definitely an outlier. It is drastically different than anything else. We're going to find the mean, median, and mode and range of the data with and without the outlier. So to help us out, because I know that for the median, I'm going to need to put them in order from smallest to largest. So that is my plan right now, is to just reorder them. All right, so I have a 10, 12. I changed it from earlier. Let's see. There's a 15, a 16, 18, 22, 25, another 25, 27, 30, 35, and 65. All right, so here's all my numbers from smallest to largest. In order to find the mean, we are going to add them all up, and we're going to divide by 13. So with the outlier, when I add them all up, I'm going to come to some number, and unfortunately I don't have that in front of me. And oh, I did redo the notes. Oh, yay me. They should add up to 315 divided by 13. Sorry, not on the screen. There we go. And I got a mean of 24. The median. So the median means the middle number. So to find that, this is the process where you go through and cross off big, small, big, small, big, small, etc., etc. And so the median with the outlier is at 22. The mode is which one appears most often. All right, so I have a 15 that appears twice. I have a 25 that appears twice. And those are my only repeaters. So you can have more than one mode. So the mode is 15 and 25. The range is we're going to subtract the highest number from the smallest. So here with the outlier, I took 65 minus 10. So this one has a range of 55. Without the outlier, so now it's like we're going to cover it up and we're going to pretend it does not exist anymore. So without the outlier, I added them all up and I got 250. But now you should be dividing by 12 because there's only 12 numbers now. And when I divided, looks like I probably estimated and I called that one 20. The median is the middle. So, whoops, that's why that was there. So now I'm going to cross them off again. So 10 and 35, cross, 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 cross. So this time, I have an even number, and so I have two numbers right here. And so if your number is in between two, you're just going to simply find the average. So I'm going to take 18 plus 22 divided by 2, and I got 20. So without the outlier, the median is 20 now. The mode, well, it's still the same. It is still 15 and 25. The range will definitely change. So the range now goes from 35 down to 10, and so when I subtract, I get 25. So when you're looking, and the question will probably be, so if you take an outlier out, where will it have the greatest impact? Well, it certainly had an impact on the mean. The median, not so much. The mode, not at all. The range, that was the most significant one. That was a change of 30. So if it says what will have the most change, it will frequently be the range that will be the answer. We're going to list a table of 12 presidents. So a lot of these I just took straight from old SAT questions, and it lists the first 12 by how old they were when they started, and it says what was the mean age of these presidents. So you should be prepared to just simply add up all their ages, and 1, 2, 3, 4, 5, 6, divide by 12, and you should get that. It says round your answer to the nearest tenth, so pay attention to what digit you're supposed to round to. Check my notes and see if you got that one right. Number 3, we have a histogram here, and it wants to know which of these following is closest, which is the closest to the average or the arithmetic mean of the seeds per apple. All right, so this says this tells you the number of seeds in the apple, and this axis tells you the number of apples that they looked at. So there were 3 seeds in 2 of the apples. There were 5 seeds in 4 of them. There were 6 seeds in only 1 of them. There were 7 seeds in 2, and there were 9 seeds in 3 of the apples. So you have to take the fact that there were multiple apples in most of these into account in order to find the mean. So here's how I did it. There were 3 seeds in 2 apples. Oh man, I'm going to have to redo this. There were 5 seeds in 4 apples. There were 6 seeds in 1 of them. There were 7 seeds in 2 apples. 7 and 2. And there were 9 in 3 apples. And hold on, when I did these notes earlier, I made a typo, so let me run through these real quick. Alright, so I have 6, 26, 14, and 27. Okay, so when I add them all up, we had 73 seeds, and it tells me right here that there were a total of 12 apples. So I'm going to take 73 divided by 12, and I get 6.083, and that is the average number of seeds per apple. And it says which of these is closest to it. So 6 is the correct one. So this is how you do this problem. I can tell that there are a lot of people that will probably just kind of glance at the histogram and they'll see, oh, well, 5 was the tallest one. Surely that must be the answer. But that is not the way it works. You're going to have to calculate all the seeds and divide by the number of apples in order to get this one correct. Number 4 says we have a scatter plot. So we will be doing that this unit. This is what a scatter plot looks like. A scatter plot means I have some data and I plot it and it doesn't form a straight line. This straight line that's kind of in the middle of all the dots, that's called a line of best fit. The line of best fit is shown. That is the straight line through these data points. It kind of like is a built-in average for all the data points. So we have a lot going on. I generally go straight to the question because I have 2 graphs here. I don't know if it wants me to use both of them or one of them or what. It says on the box plot, so this one's the box plot, of the following, which is the best estimate of the median body length of the 14 crocodiles? So it seems like they took this data here, they probably measured them, and then they created this box plot here. You need to know vocabulary a little bit. Median means middle. And so right here, that is the median right there. And so if you follow it down, it looks like the median is closer to 300, but we're talking somewhere between 300 and 350 would be the median. And when I look here, 260, nope, 300, 320, 370. So it looks like 320 is my best possible one. Why? Well, because from the box plot, that little hash right there, that tells you where the median is. That hash right there is the middle or the median. Number 5 is kind of like number 3. We have a dot plot now instead of a histogram, and it tells the ages in which babies began walking. And we have to figure out some info between the mean and the median. So this one, it looks like I am going to need to write it all out because I would like to know what the median is. All right, so a baby walked at 9 months and 10 months, 11 months. There were 3 at 12 months, so you should have 3 12s on there. 1, 2, 3, 4, 5 at 13 months. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There are 7 here at 14 months. Looks like there's going to be 7 right there. 1, 2, 3, 4, 5, 6, 7. There we go. And 15. 1, 2, 3, 4, 5, 6, 7. All right, so I listed them all out. And so now I need to find the median. So I'm going to start crossing them off. Cross off big, cross off little. That's how you find the median. All right, so right there is the median. To find the mean, we're going to have to add them up just like we did the seeds there. All right, so I'm going to go up here and use some of this space. So I have 9 times 1, let's see, plus 10, plus 11. There are 3 babies that walked at 12 months, so that's a 12 times 3. 1, 2, 3, 4, 5 that walked at 13 months, so that's a 13 times 5, 14 times 7, and 15 times 7. So I took the age that they walked, and I have to multiply it by how many babies did that. So I'm going to run these numbers and see what it totals. And I did it earlier. Did I do it earlier? Just to my calculator. Cool. Plus 11 plus 12 times 3 plus 13 times 5 plus 14 times 7 plus 15 times 7. And I get 334. And it already says that there were 25 babies there, so I don't have to count them. So I'm going to take 334 divided by 25, and I get 13.36 is the average age that a baby walked. And so they are super close, but it looks like the median is a little bit bigger. And so the mean is greater. Nope, that's a false statement. The mean is less than the median. Yes, that is a true statement. And I read them earlier. You should read them. And B is the correct answer. Ooh. Number 7 is actually a whole lot easier than it looks. So we have a fish hatchery, and they have 3 tanks for holding fish. There are 10 fish that weigh less than 5 ounces, and they're placed in tank A. All right, so there are 10 fish in tank A. We'll use that in a minute. We have 11 fish weighing between 5 ounces and 13 ounces in tank B. 11 fish in tank B. We'll use that in a minute. We have 12 fish that weigh more than 13 ounces placed in tank C. Which of the following could be the median, that means middle, weight of these 33 fish? All right, so median means middle. So perhaps you were confused about, what do I do? I mean, this one is 5 ounces, but it ranges up to 13 ounces. I don't really know what to do with that. So it talks about the middle. So hopefully, if you can just kind of, I'm going to use A to represent these fish in tank A, and there were 10 of them. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 11 fish in tank B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I have 12 fish in C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And median just means middle. So now I'm just going to go through and I'm going to cross them off one by one and see which fish should be in the middle. A fish from tank A, tank B, or tank C. It looks like B is about ready to win. Let's keep going and be certain. Absolutely. So I'm going to stop crossing off because B is definitely going to be the median one. And so if you look here, the fish in tank B weighed at least 5, but no more than 13. So can't be 4.5 because that's not at least 5. 8, yep, could be. 13.5, nope. 15, nope. 8 is the good final answer on that one. So thanks for sticking with me.